Hello guys, Oscar Hotel 8 Sierra Tango November here from Survival Tech Nord. As you can see on your screens, we have arrived at a new milestone in off-grid power for the ham shack. What you're looking at is a vertical axis wind turbine. A wind turbine which will be used in conjunction with the solar panels on the tower, along with the 576 watt-hour solar generator we built on the channel last year. We'll be combining these three systems to provide off-grid power for our lighting, computers, and radio communications throughout the year. Now, before I say anything else, I have to tell you, Ham Radio Prep is responsible for making this project possible. So for those of you interested in getting licensed or upgraded in the US, Ham Radio Prep believes so firmly in their courses, if you don't pass the FCC exams on your first try, they'll give you your money back and pay for your exam fee. In addition to this, they offer 20% off to viewers of this channel. So honestly guys, if you're in the United States and planning to get licensed or upgraded, there are very few reasons not to move forward with that now. So with that, I say stick with me and let's talk about hybrid off-grid power. It may not be immediately obvious why we would be talking about off-grid power on a channel dedicated to amateur radio. But if emergency communications or preparedness are either the reasons you got involved in amateur radio, off-grid power, or at least emergency backup power, should be of great interest to you. So what we have here is a vertical axis wind turbine. They're slightly different than the horizontal axis wind turbines you normally see in wind farms or on small boats and things like that. The main difference, and perhaps the main benefit of the vertical axis wind turbine, is the housing remains stationary. The blades move and the axle on the motor moves, but the housing stays stationary and mounted to a fixed object. If we don't care about pointing the wind turbine into the wind, it gives us a lot more installation options which we don't have with a horizontal axis wind turbine. Hybrid off-grid power might sound like a mouthful, but in the end, it simply means the merger of two different technologies. In this case, we're talking about wind and solar. Now, hybrid off-grid power is important because it allows us to supplement our primary means of power generation. For my home station, that's definitely solar power. Unfortunately, at this latitude, solar power is pretty useless during the wintertime when we literally have little or no sunlight for days at a time. So what we do have during the autumn, winter, and spring is a lot of wind, especially here near the coast where I live. So adding hybrid capabilities to my station will allow me to take advantage of the wind we have in autumn, winter, and spring without the need for upgrading our battery storage or adding additional solar panels. In fact, it's almost a no-brainer. Now, after lots of discussions with my Patreons and YouTube members, we've decided the vertical axis wind turbine needs to be up at least 10 meters on the tower. Currently, it's not even half that height because it's in a testing position closer to the ground. On the second or third week of August, we're going to go ahead and lift the vertical axis wind turbine up to the 10-meter point on the north side of the tower. This should clear up any turbulence and give the turbine a clear view to the horizon. Now, there are still a few birch trees on my property which are above 10 meters, but I'm hoping with their distance away from the tower and clear view to the sky and horizon in most directions, we can keep the wind turbine happy. So with the exception of south to southeast, the rest of the horizon looks good at that height. Just like our solar power systems in the field or at home, off-grid wind turbine generators also need battery storage. For this wind turbine, I'll be using the battery storage system we built on the channel last year. That's a 576 watt-hour lithium iron phosphate battery storage system based on Headway cells. Now, we've already put that in its own enclosure we built last year. It has 4 45 amp Anderson power pole connectors, plus a Geneson charge controller internally. Now, honestly, I've had so much good luck with the Geneson charge controllers that I'll definitely be sticking with them for the solar side of this project. On the wind turbine side of the project, it's a bit more challenging to come up with a charge controller. I know I need a wind charge controller with the dump load. I also know the charge controller has to have a boost functionality and also be RF quiet. I'm also looking for a charge controller which has programmable voltages so we can use lithium ion or lithium iron phosphate batteries. Now, I really wish Victron or Geneson or any of these other brands we normally see on the channel would come up with something or have something available for this project, but I really don't believe they do. At least I haven't found anything. If any of you have any recommendations for an MPPT charge controller specifically for wind, please let me know and leave them in the comments. Now, you may have already seen the first part of this project on my channel. That's the Skyloop antenna we put up in June of 2021 for the RMS Gateway. That's a full wavelength 80-meter loop antenna. The RMS Gateway is going to run on a Veritech standard VX1210 with a LarkBox Pro mini computer. These will be powered by the vertical axis wind turbine. Now, I also have to raise the wind turbine up to its permanent location on the tower. That's going to be up about 10 meters in height or about 38 feet. I've already got the cable up on the tower and running all the way back down into the ham shack. Now, the most important thing is ensuring the wind turbine is secure and reliable once it's up on the tower. If the reliability is good and I don't fall off the tower while putting it up there, we can move on to the measurements and answering the questions that I'm sure many of you have for the next video. So there we have it, guys. An off-grid hybrid wind solar power system. When we're talking about amateur radio emergency communications or communications for preparedness, emergency power or emergency portable power are often left out. So at least this station and the RMS Gateway will have a reliable source of off-grid power all year round. It may not be completely obvious, but the entire point of making an off-grid power supply for this RMS Gateway and my station is to support portable ham radio operators in the field. It's certainly nice making blog posts and videos, but at some point, we need to start building reliable off-grid infrastructure. Alright guys, don't forget to leave your comments and questions so I can answer them in part 2 of the vertical axis wind turbine video. And remember, if you like what I'm doing, if you like the content I'm sharing, please leave me a comment and or a thumbs up to let me know. And if it's not too much to ask, please share this video with someone or somewhere where other operators might enjoy it. Rock and roll, guys. Thanks for watching. Ciao.